Okay, sure. I mean, we can start. We'll see if someone joins. I'll let them in. So today we are going to discuss about lines and angles. So basically, what we are going to cover is we'll start with the very basics. What points are, what line segments are, what do we mean by rays, what do we mean by lines. Then we'll discuss about the various types of lines that we see. If I have two lines, how can we categorize those two lines? They can be either intersecting, they can be parallel, they can be perpendicular, right? We'll also see what are angles and what are the different types of angles. And if time permits, then we'll see what are parallel lines and what are transversals and what are the properties when we have parallel lines. And then based on the angles, we also have different types of triangles. For example, obtuse angle triangle, acute angle triangle, right angle triangle. So we'll also look into these. Okay. That point is basically any location or any point, any dot that you put in this space, that is basically a point. So when you are drawing something, when you are writing something, you must have noticed that at the starting point, you just start with a point, right? And although it is occupying some space, some physical space, that space is just a representation. Actually, point does not have any size. It will not have any size. It does not have any length or it does not have any width, right? And how do we represent a point? By just drawing a tiny dot. Okay. And using this point, we can draw various shapes and sizes, right? So, I mean, we are going to discuss some of the shapes in the subsequent slides. So these are known as line segments. So from a point, we can draw a line segment. So from a point, we can draw a line. From a point, we can draw a ray. And from a point, we can draw an angle. So point is the starting point for all the figures that we have. Okay. Now, I mean, we already discussed that we always start drawing something with a point, and we can draw a lot of things, right? In geometry, we have certain figures that we have, and there are certain differences when we draw these figures. For example, we have a line segment. So line segment, so when you draw 2 points, right? Draw any 2 point in space and then join them using a line. This will be a line segment. You have a line, right? So what is the difference between line segment and a line? So line segment, the points are fixed, the end points are fixed. You cannot change the length of a line segment. So these points are fixed, right? So it will have a definite length or it will have a definite size. You cannot change it. However, line has no end point. So if you draw a line like this, you can also change the length. So you can, if you want to increase it slightly, you can increase it in this direction. If you want to increase it slightly, you can increase it in this direction. That is why you use arrows to represent a line. That means you can increase it further. Okay. However, line segment, you have this dot to represent that you cannot extend this further. Okay. So this is the main difference between a line segment and a line. So line extends, can be extended in both direction. Line segment can be extended in, cannot be extended. It has fixed points. Okay. Then you have rays. So rays, it will have a fixed point and at the same time, it will have a point wherein you can extend it in any size, right? So you will have this point as fixed. This point you can extend in any, I mean, to any size. So the fixed point, we represent it like this. The size that we can extend, we represent it using an arrow, right? And then we have an angle. What is an angle? When you have two rays, two lines, or two line segments, if they are originating from a single point. So for example, you can see this is one ray because it has one fixed point and one point can be extended, right? You have this is another ray which has a fixed point and then this is a line that can be extended. So if they both have a common endpoint, right? If they both originate from a common point, they form an angle. So this is known as an angle. Okay. So then we have parallel and perpendicular lines. What are parallel lines? So whenever you draw two lines, so earlier we were discussing about just one lines, right? So whenever you draw any two lines, so there can be multiple cases. The first case is when they intersect, right? So they can intersect. The second case is they will never intersect. So if you draw two lines that are straight, so they will never intersect. So when two lines they are straight, or I mean they are aligned in such a way that they will never meet. When do they don't meet? When you ensure that the distance between them at any point is the same. So if you measure the distance between them at this point, if you measure the distance between them at this point, it will be the same. So that means they are parallel, they are never going to meet, right? Or they are never going to intersect. Then you'll have converging lines. So say if I have a line, it is going like this. If I have another line, it is going like this. So they are converging. Converging means they are trying to meet at a particular point. Okay. So for example, if you have a magnifying glass, right? So what you are doing using the magnifying glass, so the rays from the sun is coming, you use the magnifying glass to converge the rays of the sun to a single point, small point. So that is what we mean by converging, right? So this is when the rays are or when the lines are converging. So when they are converging, they intersect. Then you'll have a case wherein the lines are diverging. For example, in a torch, right? So when you use a torch, so there is a bulb placed at the center. So this is the bulb. It emits the light like this in all directions, right? So that is when we say rays are diverging or the lines are diverging. Diverging lines means they start from a point and then the distance keeps on increasing like this. So diverging lines also intersect. But so again, we discussed converging lines intersect, diverging lines intersect, parallel lines will never intersect. Okay. Then we have perpendicular lines. So perpendicular lines is a special case of intersection wherein the angle formed is 90 degrees. Right. So this is the angle formed when two lines they intersect at right angle. So this is known as perpendicular line. So if I have a horizontal line, this is a horizontal line. If I draw a vertical line, so what it will do, it will form a right angle like this. So then we say the two lines are perpendicular to each other. Okay. So point is a mark of exact location. So it is the starting point. Line segment, they have a definite length, right? And we represent a line segment using this symbol. So if I say, what is this? So it'll say this is a line segment AB with a overbar, right? Then if I give you a ray AB and ask what is this, you'll say this is AB array. How do you represent array? Like this. And if I give you a line AB, so you'll say this is AB, just AB. So when I just say AB, this means a line. When I say AB with an arrow over it, this means a ray. When I say AB with an overbar, it means a line segment. Okay. Now I have a question. I have two rays, right? One is AB, the other ray is BA. Are they the same? Is ray AB the same as ray BA? So see ray AB, if I just want to draw. So say I will draw two lines. What is the meaning of ray AB? So if I ask to draw ray AB, what you'll do? You'll draw a line like this first of all. Then you know ray has one end point. The other point can be extended to any direction. So you'll use this. So this is A, wherein A is the fixed point and B can be extended. So this is the meaning of ray. And when I say ray BA, so this is ray AB. Ray BA would mean B is the fixed point and A can be extended. So this is the meaning of ray BA. Okay. So I mean they are different because in ray AB, A is the fixed point while B can be extended. In ray BA, B is the fixed point while A can be extended. So that is why ray AB is not the same as ray BA. Okay. Any question or any doubt? Okay. Similarly, if I give you a line segment AB versus a line segment BA, right? So line segment AB is denoted like this. So you'll have two fixed points, say A and then B. Line segment BA will be like this. Here they are the same. Why? Because both the fixed points are same, right? So A is the fixed point here and B is also a fixed point here. Here B is the fixed point and A is the fixed point. I mean, the order does not matter here because here both the points are the same, or they are fixed, right? Here the order mattered because one was fixed, the other was could be extended. That is why the ordered I mean the order mattered right here. It will not matter here. Why? Because both are fixed points. So whether we write it as AB or we write it as BA, it will remain the same, right? And if I have lines like this AB and then another line BA, so in this case, again the order is not going to matter because both these sides are the same. They can be extended. So AB is equal to BA for line as well. Only for rays because both the sides are different. That is why order is mattering. Otherwise, for line segment and for lines, order will not matter because AB is the same as BA. Okay. Then, I mean, we have already discussed points. Then there are certain types of points as well. Say if you draw points like this, 3 points. If all 3 points lie in the same line, then they are known as collinear points. Collinear points means points that lie on the same line. Say if you just draw a line, if I just draw a line and then mark any point on it, say this point, this point, this point. So they are known as collinear. If I mark a point here, so this will not be collinear because this is not lying on this line. Okay. Then we have parallel lines. So parallel lines we have already discussed, they are the lines that never meet and the distance between parallel lines are always the same. Then you have intersecting lines. So when you have two lines, they will always intersect at a point, right? So that point is known as point of intersection. And when three lines intersect at the same point, they are known as concurrent lines, right? So when three or more lines, so see, this is the difference. When two lines intersect at a point, they are known as intersecting lines. And the point is known as point of intersection. Okay. When three or more lines intersect at a point, they are known as concurrent lines, and the point is known as point of concurrence. Okay. So when two lines are intersecting at a point, point of intersection. When three lines are intersecting or three or more lines are intersecting, it is known as point of concurrence. Okay. And this is also one important thing to remember. Two lines, if they are intersecting, they will have only one point in common. Two lines never intersect at more than 1 points. It is not possible. So two lines, they will always intersect at only 1 point. Okay. Then we come to the definition of angles. So angles are formed when two straight lines meet at a common point. So, I mean, it can be either line, it can be either line segment, or it can be either ray. Okay. So this is the first ray, this is the second ray. They are meeting at a common point. Oh. So that is why they form an angle. So this is ray 1, this is ray 2, and they are meeting at a common point. So they form an angle. Right. So the word angle means angulus derived. So this word angle means angulus. So which this angulus was derived from the Latin word which means corner. And you can see that this is a corner, right? Being formed because of these two lines. So that is what we mean by angle. Angle means corner. Okay. Just like we measure length in meter, right? We measure any quantity in kgs, right? We measure temperature in degrees Celsius, degree Fahrenheit, or Kelvin. We measure degrees. I mean, we measure an angle in degrees. Say, for example, this can be 45 degrees. So we represent a degree like this. So this is the symbol for degree, right? And how do we call this angle? I mean, the symbol for using angle is angle, and then you use this first ray. So this is A, then the vertex O, and then B. So this is how you write it. So angle AOB. So this is how you represent an angle. And this is equal to 45 degrees. So this is when I'm starting from here. You can also start from here and write an angle. So you can write B OA. So angle BOA is equal to 45 degrees. Both will mean the same thing. Okay, is this clear? Any doubt? Okay. So then there are certain examples of angles. For example, you can have acute angle, you can have straight angle. We'll discuss this further. Then you have some non-examples. For example, squiggly lines. So any random lines that you draw. This is not an angle because there is no corner, right? To have an angle, you should have a corner. Circle, you don't have any corner in a circle. That is why it is not an angle. You measure an angle using a protractor. So the instrument that is used to measure an angle is known as a protractor, right? And what is the degree? I mean, what is the unit for measuring angle? It is degrees, right? What is a degree? So if you have a complete circle, right? If you rotate a complete circle, that becomes 360 degrees, right? So if you make a complete rotation, or say if Earth is rotating around the sun, right? If it makes a complete, not rotating actually, it is revolving around the sun. So if it makes a complete revolution, that then it covers an angle of 360 degrees, right? I mean, then what is an angle? Angle is 1 upon 368. 1 degree is 1 upon 368th of an angle or of a circle. So if you take an entire circle, divide it into 360 parts, one of that part will represent 1 degree. Okay, and this is how we represent the degrees. So for example, this is 0 degree, this is 10 degree. So we have divided this into 10 equal parts, right? So this part represents 1 degree. This part represents 2 degrees. This is 3 degrees. This is 4 degrees. This is 5. So just like we measure any length using a scale, we can measure angles using a degree. And this is half of a circle, right? So the total would be 180 degree only. And if you had another half of this, like the other half, it will be 180 degree, one full circle. This is a semicircle or half a circle. That is why it has 180 degrees only. Okay, is this clear? What? Okay. So, I mean, you had units for measuring length like 1 meter, then you also had smaller units, right? Because say you have 1 kilometer, but we don't measure any small things in kilometers. Say you want to measure the size of your book. So you'll not use kilometers to measure it. You'll use centimeters, right? And even for even smaller quantities, you'll use millimeters, right? So we have different scales of units of the same unit, right? So kilometer, meter, centimeter, millimeter. So similarly, if we are interested in measuring even small degrees or small rotations, right, which is usually helpful in when we are working in astronomy, right? Because in astronomy, even a small change in rotation or revolution can change a lot of things. So that is where we are interested in even smaller degrees of rotation, right? So in such cases, what we have is we have even smaller units, which is known as minutes and seconds. So this is different from the minutes and seconds that we have in our clock, but very similar. So if you write 1 degree in minutes, so 1 degree will be equal to 60 minutes, and 1 minute will be equal to 60 seconds. So they have the same value, but they are different from the time that we study, right? So this unit is different from the time unit. So 1 minute is equal to 60 seconds. Yeah, go ahead. You have a doubt? Yeah, go ahead. Yeah, I mean, it is just a division that you do, right? So to make this more meaningful, what you do is just like we divide 1 hour into 60 minutes, right? So that is how we divide 1 degree into 60 minutes. So see, you use, okay, I mean, we can start from the very beginning. So see, I mentioned initially that when you make a complete rotation, it is 360 degrees, right? Why is it not 100? degrees. When we are completing a full circle, why only we are calling this as 360 and not 100 degrees? Because I mean, the usual convention that we follow is if we are making something complete, it means 100, say 100 percentage, 100 marks. So why, if we complete a whole revolution, we don't use 100 degrees to represent that and we use 360 degrees? So, I mean, the choice depends on what the application is. So we use 360 because 360 has a lot of multiples. 360 can be divided by 2, it can be divided by 3, 4, 5, 6, 7, not 7, 8, and then 10, 12. So a lot of numbers can be a factor of 360. But 100, there are unlimited factors of 100. So we use 360 because, say, if I say I want to make one third of a revolution, so that will be 360 upon 3, which means 120 degrees. If I had 100 as the complete part, if I had used 100 instead of 360, I would have said it would be 100 upon 3. And then I'll have difficulties in solving this fraction, right? So again, because of that, what we do is we use 60 and not 100, right? So the scale also depends on the application we are using. Is this clear? Or do you have any question? Okay. So just like we had these divisions of degrees, right? So this is 0 to 10 degree. So if you just pick any 1 degree, right? You can divide this 1 degree into 60 minutes. And if you further take that 1 minute, you can divide that 1 minute into 60 seconds. Okay. So if I ask you, what is the value of, I mean, 1 degree or say 2 degrees, how many minutes? Can you tell me? No. So see, 2 degree is equal to how many minutes? The question is 2 degree is equal to how many minutes? You know 1 degree is how many minutes? Yeah, it will be 120 minutes. Very good. So you know 1 degree is 60 minutes. So 2 degree will be 60 times 2, which is 120 minutes. Right? Okay. So once we have measured the angles, so using a protractor, so we'll get different. So I mean, we can draw multiple angles. So one can be like this, one can be like this. So I mean, we can join two rays in multiple ways, right? Like this, and like this. So there are many ways in which we can join two rays, and each of these combination corresponds to a different types of angle, right? For each case, we'll get different values or different degrees, right? This will be a different degree, this will be a different degree, this will be a different degree, right? Because the corners are different because of the alignment of the rays. So I mean, we can classify angles based on the value that we get by measuring them. For example, this is one case wherein the angles are less than 90 degree. What does, if you look at this, so 90 degree means if you draw a line like this, so if you just draw a line like this, and if you draw, let me use another color. So if you draw a line like this, right, and another line should be like this. So this represents 90 degrees. Okay. 60 degree if you have to draw, so one line should also always be here. And then the other line should be like this. So this is 60 degrees. If you have to draw 30 degrees, one line should be here, the other line should be here. If you have to draw 150 degrees, so one line should be here, the other line should be here, like this. So this is how you use a protractor to draw different angles, right? So, I mean, you have different classification of angles based on that, or different types of angles. So, if you have drawn an angle that is less than 90 degree, that is known as an acute angle. Okay. So, acute angles are the angles that are less than 90 degrees. So, 45 degrees, it is an acute angle. 20 degrees, it is an acute angle because these are less than 90 degrees. Right angle, so these are the angles that are exactly equal to 90 degree. Right. So, I mean, when we were discussing about perpendicular lines, we saw this piece, right? You have one horizontal line, you have a vertical line. If you join them, you have a 90-degree angle. So this is how you represent a 90 degree, right? So both lines are straight or looking straight. So that is why it is known as a right angle, right? So if an angle is less than 90, it is known as acute angle. If it is equal to 90, it is known as right angle. If it is greater than 90 but less than 180, it is known as an obtuse angle. If it is exactly equal to 180, it is known as a straight angle. So see, we are getting different groups. Less than 90, acute, equal to 90, right, greater than 90, but less than 180, obtuse, equal to 180, so it will be a straight. Then greater than 180, but less than 360, it will be reflex. And then exactly 360 will be full angle. Okay. So what we are doing is, I have a line like this. I have another line like this. Now we start moving. I start from here. Right. I start moving like this. I start traveling this path like this. Okay. So if I start from here, I am at 0 degrees. So this is 0. Now if I keep on moving, right, till here, right, so till here, I am forming an acute angle. When I reach here, I formed a right angle. And then when I started moving from here to here, I am forming an obtuse angle. When I reached here, I formed a straight angle. And then when I'm moving from here to here, I am forming a reflex angle. And when I reached here to my starting point, I traversed a complete full angle or a whole angle. So this is how we classify the angles. Any doubt? This is 230. What type of angle is this? Is it an acute angle? Is it an obtuse angle? Right angle, straight angle, reflex angle, or full angle? So see, whenever you get questions like this, you have to classify angles. So first of all, look at the angle. You have specific cutoffs. Like the first cutoff is 90, the second cutoff is 180, the third cutoff is 360. So first of all, check, does it lie between 9 or say you can start with 0. So the first thing that you check is, does it lie between 0 to 90? No, it does not. So it is not an acute angle. So if it lied between 0 to 90, it was an acute angle. Then you'll check, does it lie between 90 to 180? It does not. But if it lied between 90 to 180, it would have been an obtuse angle. Then you'll check, does it lie between 180 to 360? It does. So it is a reflex angle. Okay. So this, when it is exactly 90, you call this as a right angle. When it is exactly 180, you call this as straight angle. When it is exactly 360, you call this as a whole angle. Okay. Another question, say 135. What type of angle is this? Yeah, yeah, very good. 180. What type of angle is this? Very good. Now say 45. Yeah, good. Yeah, so I hope this is clear to you. Then we have another types of angles. I mean, this was the angle wherein we were only classifying one single angle. Now we have two angles. So say if I give you two angles, say one is 30, the other is 40 degrees. So you take their sum, you add them. If they come out to be 90 degrees, then they are complementary angles. So here you'll check 30, one angle is 30, the other angle is 40. You add them, you're getting 70. So they are not complementary angles. Okay. If I give you an angle 60, the other angle is 30. You add them, they are coming out to be 90. So they are complementary angles. So two angles are said to be complementary if their sum is equal to 90 degrees. Okay. And two angles are said to be supplementary when their sum is equal to 180 degrees. Is this clear? For example, 120 and 60, their sum is 180 degree. So they are supplementary angles. Okay. 45 and 45, their sum is 90 degrees. So they are complementary angles. Okay. Any doubt? Okay. I'll assume no doubts. So say if I have an angle X, right? Then I say if I'm given an angle X and they are asking me to find the complementary angle for X. Okay. So I know that the complementary of X, if I add it to X, it must be 90 degrees. Say if I, let us start with a number first. If I give you a number 20 and ask you find the complement of 20. So what will be the complement of 20? Yeah, it will be 70. So what you do, you just, because you know that complementary angles add up to 100, so you'll just write 90 minus 20, which will be 70. Right? So if I have 20 as an angle, the complement will be 70. Now if I say give you a number 35, what will be the complement of 35? 90 minus 35, which is 55. Right? So if I give you a general number, say variable x, be the complement of x. Can I write it as 90 minus x? Because see, if it was 20, I did 90 minus 20. If it was 35, I did it 90 minus 35. So no matter what the angle is, it I should always subtract it with x, I mean with 90 to get the angle. Right? Is this clear? So when I have an angle as x and I want to find the complement, it should be 90 minus x. Okay? So we'll try to solve this question. So find an angle equal to 5 times its complement. So you have an angle that is equal to 5 times its complement. Right? So you can assume the angle to be x. Right? So the complement of that angle is 90 minus x. And it is given that the angle is equal to 5 times its complement. So x is equal to 5 times its complement. So we'll write x is equal to 5 times its complement, 90 minus x. Right? And if you solve this, you'll get x is equal to, what is 5 times 90? 5 times 90 is 450. Right? And then what is 5 times x? You'll get minus 5x. Right? Then you can take this minus 5x here. So it will become 5x plus x equals to 450. So if you add these two variables, you'll get 6x. 6x is 450. So the value of x will be 450 upon 6. Okay, is this clear? Uh, okay. So then you can further simplify this because they have some common factors. So if you divide 450 upon 6, so if you divide 450 with 6, you'll get 76 as the answer. 75, right? So x is equal to 75. And if I ask you find the complement of x, what will be the complement of x? So if an angle is 75, what is the value of that complement of that angle? No, so that is the supplement. Complement is 90 degrees. The sum should be 90. Yeah, it will be 15. And then you can check the answer because it says find the measure of an angle equal to 5 times its complement. So this is 15. So the angle is 5 times of 15, right? Which is 75. Okay. Okay. Now we'll just discuss about the types of triangles. So see, what are the different types of triangles that we have? So we can classify triangles based on either their sides or their angles. Okay, so the first type of triangle wherein all three sides of that triangle are equal. First of all, what is a triangle? Triangle is a figure that is made up of three lines or line segments. So when you have three lines like this, you form a triangle, right? And how many angles does a triangle have? So basically, yeah, it will have three because it has three corners like this. It has three vertex or points. It has 3 points and it has three lines. So it is made up of three lines, 3 points, and three vertex. Sorry, three lines, three vertex, three angles. So a triangle is a figure that has three vertex, three lines, and three angles. Okay, so when you classify them on the basis of their sides, so you call this as triangle ABC. So you can name the vertex, right? So this will be triangle ABC. So when you classify this on the basis of their side, so the first case can be, so you have drawn a triangle wherein all three sides are equal. Okay, so when all three sides of a triangle are equal, they are known as equilateral. Equilateral triangle. Okay, so this is the first type of triangle. The second type of triangle is when you have only two sides equal and the third side is not equal. So say this side A, B, C. So for example, this side and this side is equal, this side is not equal. So such a triangle wherein two sides are equal, only two sides are equal. So such types of triangle is known as isosceles. Then you have the third type of triangle wherein no sides are equal, like this. So in this triangle, you don't have any side that is equal. So this is known as a scalene triangle. Okay. So see, equilateral triangle, when you are drawing equilateral triangle, all three sides should be equal. When you are drawing an isosceles triangle, say for example, you are drawing a triangle like this. So you make sure that these two sides are equal. You've drawn. The third side is different. Okay. So say if this is 2 centimeter, this is also 2 centimeter. but this is 3 centimeter. Here, all three are 2 centimeter. So 2 centimeter, 2 centimeter, 2 centimeter. So you have drawn this triangle such that all three sides are equal to 2 centimeter. So that is why this became an equilateral triangle. You have drawn this triangle such that one line is of 2 centimeter, the other line is of 2 centimeter, but the third line is of 3 centimeter, which means two sides are equal, but one is not equal. So that is when you have an isosceles triangle. Equilateral scalene triangle, when you have this as 1 centimeter, this will be 4 centimeter, and say this is 5 centimeter. So you notice that none of these sides are equal. So that is why it becomes scalene triangle. Okay, is this clear? You have any doubt? Okay, I assume no doubts. Then on the basis of angles, if you just look at the angles, so you can have again different types of triangles. The first one is acute angled triangle. Okay, acute angled triangle. Acute angled triangle. What is an acute angled triangle? Wherein all the angles are acute. Okay, that means all the angles must be less than 60 degrees. Say this is 60 degree, this is 30, or say this is 40 degrees, and this is 80 degrees. So all the angles are less than 90. So then it becomes an acute angle triangle. Okay. Another type of triangle you have is a right angle triangle. Right angle triangle means at least one of the angle is right angled. So it means one of the angle must be 90 degrees. So one angle must be equal to 90 degrees. So if one of the angle is equal to 90 degrees, then it is a right angled. So then you call that triangle as right angled. And finally, you have an obtuse angle triangle, right? Obtuse angle triangle means when any one angle is obtuse. So for a triangle to be acute angle, all the angles must be acute. Even if one of the angle becomes obtuse, then it will become an obtuse angle triangle. This is 40 degrees and this is 20 degrees. This becomes an obtuse angle triangle. So again, acute angle triangle, all the angles must be acute or less than 90 degrees. Right angle triangle means one of the angle, at least one of the angle or one of the angle is greater than 90 degrees. Okay.